so that we can cover the whole earth in say 4 or 5 days, or especially a country like India can be covered in 4 or 5 days. That is WIFS camera, because our focus is on the greenery, the vegetation, the forest cover, vegetation map. Okay, so that is a different thing altogether. So we have broadly three types of cameras in a in a remote sensing satellite like ours. So that is what precisely I have mentioned. Okay, so vegetation mapping is WIFS. The other are for specific photography, and LIS camera can be used for linear image. That means it is for the depth of the 3D pictures also can be taken. Now, there are applications of remote sensing satellite. Many applications are there, a series of applications are there. See, spying can be there for this panchromatic as well as the LIS cameras are used for spying purpose where the resolution power is less than 1 meter. If the resolution power of a camera is less than 1 meter, then it can be used for spying purpose. Okay. Now, some of the applications like groundwater prospecting. Okay. So, to understand this can be because the various electromagnetic radiations reflected, scattered, or refracted and what not, even emitted also, if at all, when the groundwater will not be emitting it. But if the electromagnetic radiation is emitted even from underground, it can be used for mapping the groundwater, how much groundwater and which depth the groundwater is available. All these things can be mapped by using remote sensing satellites. Also, it is elaborately used in CAPE and FUSSEL. Okay, 2 programs. All the 3 cameras are very crucial. There is nothing that this is more crucial or less crucial, because different applications are there. Okay, so groundwater prospecting, LIS camera will be very important in groundwater prospecting, because we will have to know the depth also, how much water is there. So that can be done by the LIS camera only. CAPE means crop acreage and production estimate. Okay, crop acreage and production estimation. CAPE. So how much crop CAPE, okay, how much is a particular crop cultivated across India? It can give a complete clear picture how many hectares of land we are cultivating rice, even different varieties of rice, different varieties of wheat, or maybe millets. It can be identified because different crops will be emitting different electromagnetic radiation, different amount of infrared rays, different amount of heat from the crops. So it can easily be identified by using a WIFS camera maybe. So let us not get into which camera is doing. The remote sensing satellites are giving this picture or this idea. CAPE and also FUSSEL, another program called Forecasting Agricultural Output. Using space, agrometry and land based observation. What is the full form of FASL? Forecasting agricultural output using space, agrometry and land based observation. Forecasting agricultural output by using space, agrometry and land based observation. So we can also talk about how much is the product. When we say in this particular year the total food grain production in India is 200 million tons or 220 million tons. How are we able to tell this? we are taking the help of remote sensing satellites also. Then in the agroclimatic planning, see, our country is divided into various agriculture and climate, agroclimatic regions, and planning is required, and this remote sensing satellite information is very crucial for this planning. And we have, a series of agroclimatic regions are there, and in there we are helping in the planning purpose. Even the drought affected area, every year photography will help. Flood affected, coastal erosion, in many places there is coastal erosion, photography will help us. Okay, any desertification, of landscape, especially in the semi-arid regions, desertification is a common problem. So we are able to take the idea about, and even wasteland mapping, potential fishery zone forecasting, where do we find fishes? Potential fishery zone in oceans, because the energy, the heat energy produced by fish, if there is a large number of fishes in a particular region, we call a school of fish. If there is a school of fish, the temperature of the water will be different, and using that, the satellite image will tell you, okay, this is the area where the fishes are there, and this, in this direction the fishes are moving. So the potential fishery zone. Then also biodiversity characterization, we need our biodiversity, especially in a country, we are a ecological hotspot. Biodiversity characterization, meaning to identify the various biodiversities of the India and the world. In fact, we can use it, and identifying especially the hotspots like western Himalayas, eastern Himalayas, the entire southern hill complex, okay, the Western Ghats, Andaman Nicobar. These are the 4 major biodiversity hotspots of India. And biodiversity characterization, meaning identifying and locating and pinpointing the various biodiversity. Okay. Then, as I already said, also the resource mapping, and even the resources, especially for mining purpose, what kind of resources are found where, like aluminum or iron ore or various other minerals. The mineral resource mapping, mineral resources. Then snow melt runoff forecast. Snow melt runoff forecast. And it's a big problem in global warming, you know it very well. Also, not only that, even we have traced the lost rivers, like underground channels, like the sourcing and tracking Saraswati river, which has gone underground in the deserts of Rajasthan. So this tracking of underground water channels, snow and glacier investigation, snow melt runoff and how is it going and all, snow and glacier investigation, coastal zone mapping, I already said, the coastal erosion I already said, and even the issues related to mangroves, coral reefs, investigation, coastal zone mapping, Then various archaeological applications like the lost city of Dwarka. We have identified and we are having elaborate ideas about the submerged city of Dwarka using remote sensing. So, archaeological applications. Okay. And also watershed development, command area development, watershed from where a river catches, the catchment area, and the watershed development program. In a watershed, how to use the water and which are the areas from where a particular river is collecting water, that is the watershed we are talking. Command area development program, CAD. In a dam, when a dam is constructed and when we say that we will irrigate so much of area, the remote sensing satellites will help us in identifying whether the water is reaching where all we are claimed and how fast it is reaching and other aspects of it, whether we are utilizing the resources properly, whether we are able to take the water to the designated spot. All this in command area development program. Sedimentation survey of reservoirs. Okay, sedimentation survey of reservoirs, water logging, salinity mapping. I forgot salinity, water logging and salinity. Of the wasteland and all. So, then even the National Geographic Information System, the GIS, Geographic Information System, we are digitizing the whole map of the country. We need to have electronic information, precise information. Also, that is the GIS is Geographic Information System. Geographic Information System, GIS, National Geographic Information System, to digitize the entire mapping. Like we can use it then for the all these Google map and all. Ultimately, it is based on the digitization of the the whole map. Even to lay a new road, the new road alignments, we are using remote sensing satellite information. Like new greenfield expressways which we are constructing. For example, now a construction is going on Delhi to Mumbai, a new expressway, entirely different road. Its alignment, which is the shortest and all, alignment is fixed with the help of remote sensing satellites also. New road alignments, airport, airstrips, construction, new rail lines. So, a series of applications. We cannot, and even in the urbanization, in urban areas, any illegal encroachment into government land, illegal encroachment in urban management, in illegal encroachments. See, you need not go and check every day whether a government land is encroached or not. We can take, if the satellite photographs will tell you if there is an encroachment. Even an illegal construction, illegal encroachments. See, various municipalities and corporations will give permission to construct a building, but whether this building is constructed as per the plan, if there is an additional construction in that, we can easily track illegal encroachment, illegal construction, any road blockage. In urban planning, a series of applications are there using remote sensing satellites. So, huge application. In every aspect of our resource management, remote sensing satellites will come into play. So, what is remote sensing, how is it done, and what are its applications? I hope it is very clear, and please make sure that you are ready for an answer. I have given 22 different applications, but you need not have to explain everything, but many of them you will have to explain and tell that these are some of the applications of remote sensing satellites and remote sensing program. Now, these satellites are normally, now some of the examples of satellites. Okay. Now, when you talk about that, we started with IRS 1A, 1B, 1C and 1D, Indian remote sensing satellites. Indian remote sensing satellites. And we have launched this IRS 1A, 1B, 1C and all with the help of Russia at that time. It was in 1990s. Okay. One second. So, the first one, as I mentioned, that was in IRS category. One second. Yeah. So, IRS 1A was launched in 1988, sorry, not in 1990s. IRS 1A 1988. Then IRS 1B was launched, that was in 1991. Okay. This is both by Russia, from Russia, it is immaterial. IRS 1C, that was launched in 1995. Then IRS 1D, it was in 1997. So, these were the 4 initial satellites of remote sensing in India's history. All of them were successful. First 3 were launched from outside. Then we developed our own PSLV. Okay. We have launched our own PSLV, PSLV C1. Polar Satellite Launch Vehicle. The name itself has come because these satellites are launched in the polar orbit. So, PSLVs, otherwise this P has come only because we are launching in an orbit which is revolving around the earth in a polar orbit. That is why the P word has come in that launch vehicle. So, remote sensing satellite, primarily the PSLV's purpose was to launch remote sensing satellite. That is why the word P word has come in that. Anyway, so PSLV C1 commercial launch 1, it was in 1997. Before that, some demonstrative satellites were there, so launches were there. Forget about that right now. So, IRS PSLV C1, IRS 1D, all these cameras were there, WIFS camera, LIS camera, panchromatic camera, all of them were there. Okay. इसको बताओ ना यार क्यों परेशान कर रहे हैं. So, PSLV C1 first launch, or first launch means first commercial launch before, after some of the development flights. So that was in 1997, we have launched it. Now we are talking about the PSL, see this remote sensing satellite, India has in a mastery in the remote sensing satellites right now, India is an expert, and the latest one which we have launched, okay, in the remote sensing category, of course it was the PSLV C51, just imagine, okay, PSLV C1 in 1997, we will talk about PSLV separately, C51, 51st such launch, okay, and we launched C51, we launched a commercial launch, it was not for India, we have launched a satellite called Amazonia 1 for Brazil in February 2021. A couple of months before, we have launched PSLV C51. Then before that, we have launched another one called PSLV C49, and forget about that, we have launched another one called EOS, Earth Observation Satellite 1. A new satellite naming has started, that was in November 2020. Then we have also launched another one called RESAT 2BR1. That was in December 2019. Anyway, I will just come to that. So we have launched a series of satellites, more than 50. See, from the first launch, the first commercial launch which we have launched, the PSLV C1, now C51, you can imagine, we have launched more than 50 remote sensing satellites from our, almost 50 remote sensing satellites from India already, and initial satellites, I have already said this. Now let me see the latest ones, a couple of them you might have already seen it, but still a couple of points I would like to add. For example, Amazonia, I said we have launched in February 2021. Amazonia, February 2000, in the current affairs also it might have been discussed, but still 2-3 points I would like to say. One is, it is launched by our PSLV for Brazil. It is for National Institute for Space Research of Brazil. National Institute for Space Research for Brazil, and is the first, in fact, after the creation of NSIL, National, the New Space India Limited, New Space India Limited in 2019. This is, Amazonia was the first commercial mission of NSIL. Okay, Amazonia was the first commercial mission of NSIL, and it can also complete the whole Earth in 5 days, especially the WIFS camera. Using the WIFS camera, it can cover the vegetation of the world in 5 days. Okay, in 5 days it can cover the whole world, and again it is it has a resolution power is less, because 1 meter and all means it will take more time. So if the resolution is only, the resolution is around 60 meters, and from a position it can cover almost 850 kilometers swath. Swath means the broad area which can be covered. Swath is almost 850 meters, it seems, and it completes the whole world in 5 days. Okay, that is how it has been done. So it's basically to study the Brazil and Amazon, and especially the deforestation of Amazon. This is mainly for to study the deforestation of Amazon. It's a big mess in Brazil right now. They are destroying the forest, and whatever is happening in Brazil, it is a major, it's a matter of concern for all of us, for the global warming and biodiversity, because Brazil has more than almost 60% of the global biodiversity there, and if it is destroyed, it is a big loss for the whole world. So we have launched one for Brazil. This is called Amazonia 1. It was in February 2021. Don't forget, February 2021, Amazonia, and PSLV C51 was used. Then another remote sensing satellite which was recently launched by India, again in current affairs you might have seen, but still I am also just telling, EOS-1. Earth Observation Satellite 1. We are starting a new numbering or new naming. IRS and other names we were using. Now we are starting with a new one called Earth Observation Satellite 1. Okay. And this is another radar imaging satellite. Okay. Radar. What is radar? What is the, that is radio. Radio waves are used. Okay. In radar, what are we trying to do? It is, we are doing, or we are using the radio waves okay. It's a object detection system. Okay, by using radio waves. It is nothing but it is a radio detection and ranging. Okay, radar. Radar full form, radio radar is used in aeroplanes to identify the incoming aircraft, in missiles, everywhere, to identify, locate and identify. So the same thing, the same radio waves are used for something. See, now during the night time, imagine a scenario, you will get it, the picture very clearly on Earth, and during the night time you want to take photograph, there is a limitation because light is not there. Now, if you can send down a radio signal by the satellite, and by the time it reflect back within a few seconds, or rather in microsecond, it will reflect back and reach the satellite. And using this radar, you can identify objects the way the radio signals are coming back. This radar can, or the satellite can immediately identify the objects without seeing it by using radio signal sent by the satellite. So this is very important for spy purpose, spying. This is very important for night, vision, or other identifying. Even it can be used for even identifying moving vessels in sea, moving ships in the oceans. Radar imaging, and we already have launched RESAT, and this is very important for military application. RESAT, radar imaging satellite. We have already launched many. These are all for spying, for military application, for secret applications. Okay, so we were already doing it. So we were already having it. We have a series of RESATs, radar imaging satellites. Now, as part of the radar imaging satellites, we have already launched, RESAT, 2B. Earlier we have launched RESAT 2B. Then we have also launched RESAT 2B R1. RESAT 2B R1. Now, there RESAT 1, then there is a 2, then RESAT 2B, now RESAT 2B R1. Now, a third one we were planning called RESAT